Okay. We had briefly discussed number 9 before we left for the day, because I was desperately trying to fit it all in there. Okay, so remember we said that this is going to be your little lifeline, right? Is this little guy. And he is stapled into this key formula packet. So this packet that's back there by the study guide has your chapter 8 and 9 formulas. It has your Z numbers for chapter 8. It has your T table, which you're going to need for 8 and 9. And then it has that little cheat sheet packet that I had put together for you guys to kind of help with chapter 9. So it's got it all stapled together. And then if there's anything you want to write on that too, you know, feel free to do that. But okay, so we were on our little cheat sheet here and we said that we have to know what page are we on. Is sigma known? Is sigma unknown? Are we dealing with proportion, right? So as we read through this, just to kind of refresh your memory a little bit, it's really hard to tell if sigma is known or unknown. It's obvious it's not a proportion because we don't have a percent and it doesn't say the word proportion. But as we read through here, I see the word standard deviation. So it's not a proportion, but what you might think is that sigma is known. It's not. Remember, it's that really sneaky situation where you have to read it and do some reading comprehension. It's talking about a sample of 18 observations. This sample produced a sample mean. There's your X bar and a standard deviation. And because that's in the same sentence as the sample, that is S. It's not sigma. This is sigma unknown. So it's super, super sneaky. So we're going to be on this page with the sigma unknown, right, that we're dealing with. So N is 18, X bar is 42.4, S is 8, okay? And then our alpha is 0.01. That's our significance level. It gives us a null and an alternative hypothesis. And because that's not equal to, it's a two-tailed. Okay, so we have a two-tailed sigma unknown. But then when you read the directions, it wants p-value approach and critical value approach. So we're going to have to do both. Okay, well, the good news is that whichever one you want to do, whichever one you choose to do or have to do, if you look there, step 1's the same for both. We still have to find T observed. So no matter what, we have to find this formula, which we also said is sometimes called the test statistic. So don't forget to make that note. That's our test statistic. Okay, so no matter which approach we go with, and this wants both, we have to find T observed. So we're going to have X bar, oops, put my decimal in the wrong place. Okay, minus mu. Now remember, everybody forgets where mu is. Mu is with your null. So here's your mu, 46, divided by S of X bar. Okay, we don't have that. All we have is S. So your S of X bar is actually S divided by square root of 10, or square root of n. So that's what we have to use. So let's see, we're going to have 8 divided by square root of 18. What did I come up with that? I think I got 1.8856. Okay, so that's what's going to go down here. There we go. Okay, and my T observed then is negative 1.090. Okay, there's my T observed. Now that I have that, I can go and look at each approach and figure out which approach that I'm going to use. So why don't we do the p-value approach first? Okay, remember, they are so totally different. I really hate that they make you do both of them at the same time. Okay, so here we go. We go to p-value approach. Now this is different. this says for sigma unknown, our p-values are a range. We haven't had that before. That's how it is for sigma unknown. So it's a little different. Okay, we found t observed. We're going to find our degrees of freedom. That's just n minus 1, right? So degrees of freedom is going to be 17. All right. Now, next thing it says, using degrees of freedom, find the correct row on the t-chart. Okay, so I've got to get my t-chart. Locate the two t-values that your t-observed falls between. Okay, so here's my t-chart. My degrees of freedom are 17. Okay, so here's my row. Okay, what I want to do is look inside this row and I want to find, look at these numbers here and find where does your t observed fall in here. Now, all these numbers are positive and our t observed was negative 1.909. We're just going to make it positive and find which one it falls between. So negative 1.90 or positive 1.909 would fall between here, right? It falls between these two. So we go straight up. These are our two p values that we're going to use. Okay, so it's going to be between 0.05 and 0.025. Now, this is kind of strange because the smaller one's on the right and the bigger one's on the left. So you're going to have to swap them when you do your inequality. Okay, so we're going to say that our p-value is between 0.05 and 0.025. Now, here's the other little strange thing, which again is why you have the little cheat sheet. If we only had a one-tailed test, we would be done. That would be our p-value. But if you have a two-tailed test, be sure to multiply these values by 2. We have a two-tailed test, we have to multiply this by 2. Remember, for the p-value approach, your p-value is the area under the curve. So you just told me this is one area under the curve, but we have two areas under the curve because it's a two-tailed test. So I'm going to have to multiply both of these by 2 because it's a two-tailed. So our p-value is actually between 0.05 and 0.1. And that's only because it's a two-tailed test. Okay, otherwise we would be done and that would be it. All right, so for your p-value approach, you have everything you need. Now you're going to compare alpha and your largest p-value. That's what you're going to do. Now remember, the key with p-value is the smaller the p-value, the more significant it is. So if alpha is bigger than your p-value, you reject. Okay, so our alpha is 0.01. That's our alpha. Our biggest p-value is 0.1. Okay, so 0.01 is definitely smaller, right? Okay, so we are going to fail to reject. Okay, we're going to fail to reject. All right, so it may take you a minute to get back into this stuff because it's a whole nother language, right? It's kind of hard to remember how to deal with all this. All right, so that was the p-value approach. We got our p-value, it was a range. We had to multiply it by 2 because it was two-tailed and then compared it to alpha. And because that p-value was so darn big, we rejected the null, or failed to, I'm sorry, we failed to reject the null. Okay, now this also wants the critical and observed value, which makes me so happy because to me, it's the one that makes sense. So I like the critical value approach. Okay, critical value approach, I get to make a picture and I am a visual person. So we have 2 rejection regions Here they are, which means we're going to have two critical values, right? Because it's a two-tailed test. We're going to have a negative critical value right here. We're going to have a positive critical value right here. This is our non-rejection region, okay? And then remember, our alpha happens to be these two regions added together for critical value. So because there's two, I divide by two. It's like everything you did for p-value, you do the opposite for critical value. So each one of these guys is going to be 0.005 for his area, okay? All right, so I need two critical values, and then I'm going to see where does my observed value fall. All right, here we go. I found my T observed. Now I need to find T critical. So from the T chart, using alpha as the area and the degrees of freedom, I'm going to find it. And then it reminds you, because it's the opposite of p-value, here we multiplied by 2, here we have to divide by 2, but we already did that when we drew our picture, so we don't have to worry about it, okay? So I'm going to go back to my T chart, okay? My degrees of freedom are 17. And then when I divided my alpha by 2, what did I get? 0.005. That's my area. And so I'm just going to go down here. My critical value is 2.898. Okay. Would that be the one on the right or the one on the left? The right, because it's positive. What's the one on the left going to be? Negative 2.898. Okay. So those are the critical values that it wanted. Okay. And now just to check and make sure we come to the same conclusion, if I take my T observed, my negative 1.909, where does that fall on this number line, negative 1.909? It's kind of over in here somewhere, right? Because this is negative infinity and this is positive infinity. So it would be somewhere over in here. This is 0. Nope, it's right over in here. Good gracious, people, help Miss Holcomb out. Okay, negative 1.909. Okay, somewhere right in here, right? So it's in the non-rejection region. So I'm going to fail to reject the null. And there we go. Okay, we came to the same conclusion. No wonder y'all are looking at me like I'm crazy. All right, is everybody okay with that? I know it's crazy looking, but I think this will help you if you just follow the steps, okay? All right, let's do another one of these. So this will help you in your Wiley. We're now going to go to number 12. Let's see what's going on with this guy. Okay. All right, I've got papers everywhere. All right, so according to an estimate, the average debt for college graduates was $34,400 in 2010-2011. A random sample of 485, okay, there's our sample, showed that this year's average debt is 38,000. Okay, what do we think 38,000 is going to be? It's in the same sentence as our sample, so it's our sample mean. Then if we keep reading with a standard deviation of 5360, what do we think 5360 is going to be? S. So this is, again, a sigma unknown. And I just want to make sure you guys see that. The only way it's going to be sigma known is if it actually uses a sigma, or if it actually says population standard deviation. If you don't see that population word, it's the other one, okay? All right, does the data provide significant evidence at a 5% significance level? Okay, let's stop right there. Significance level's alpha, and it needs to be a decimal. So 5 divided by 100 is 0.05. to conclude that the current average is higher than 34.4. And then, of course, use both approaches. So just like the other one, we have to use both approaches. All right, we do not have a null and we do not have an alternative written for us. We have to write it ourselves. So here we go. We're going to write them both ourselves. Okay, we use mu. All right. So the alternative is what we're testing. And that's where this little phrase comes in, higher than. So is my test going to be greater than, less than, not equal to? Higher than would be greater than, right? Which means that your null is just equal to. Okay, it's always fine to make your null equal to, and then you make your alternative one of those three, not equal, greater than, or less than. Okay, so since I'm greater than, what kind of test do I have? Right tail, left tail, two tail. Right tail. Okay, perfect. I have a right tail test now. Okay. All right. So I have everything I need. I know to be on this page because sigma's unknown. I know I have a right tail test, and I know I'm going to have to do both of these different approaches. Okay. So since I have to do both anyway, let's go ahead and find T observed. Okay. So T observed is going to be X bar minus mu. Now remember, they didn't give us mu really directly in the sentence, in the paragraph, right? We just kind of had to infer it. And then it's going to be divided by S of X bar, which we have to find. And that's the formula up there on that page for you. So it's going to be 5360 divided by the square root of N. Okay. I ran out of room to write him, so I'm just going to throw him in there. Let's see, what did I get? I got 243.385. Always try to go out 3 or 4 decimal places on that guy, just to really make sure your numbers are right. Okay. And my T observed ended up being, I got a 14.791 on him. Okay. That's about all those two approaches have in common. So I'm ready to kind of tackle each approach. Okay, so let's do p-value first. I always like to just get him out of the way. Okay, so we go to our little page. We already have T observed. Now remember, p-values are a range only for sigma unknown. That's the only one, but they're a range. So we're going to find degrees of freedom. We're going to look inside our chart, and we're going to go straight up and find our formula. So 485 minus 1, whoa, holy moly, 484 degrees of freedom there. Okay. And then we know our p-value is going to be a range between two of our top numbers, right? Okay, so if we try to find 484 degrees of freedom, that's not going to happen. But remember, anything bigger than 75, we just call it infinity. So we're in the bottom row down here of our T chart. Okay, can you guys kind of see that way down there? All right. Okay, so I'm looking in the bottom row, and let's see. What I notice is, oh, wait a minute. Did I do the wrong one? Put the wrong stupid one up here. I probably did. I was trying to avoid one of them, and I bet I put the wrong one up here. Yes, I wanted to do number 11. Oh, well, dang it. Okay, we'll just do this one. That's fine. Okay, so anywho, I'm trying to find my T observed, which was 14,791. Well, the biggest I see is 3.09. Everybody see that? So I'm like way out here. I'm not actually between two columns, but if you go straight on up, look at that. Ms. Holcomb made you another column. Okay, so these guys on each side right here were given to you on the front. If you take an imaginary step on each side, this is only the one on the packet, I think. The one that you may have that's loose may not have this, but you may want to write a 1 all the way over here on this side. and a 0 all the way over here. Okay. So if I go straight up, I'm really between 0.001 and 0. Okay. I went ahead and wrote these in for you on the final exam packet that you're going to use, but I didn't write it on the ones I handed out that are just single sheets. All right, so I'm looking at 0 to 0.001 for my p-value. Okay, that's my range. Now, do I have to multiply this by 2 or do anything to it? No, because it's not a two-tailed test. I will tell you when we get to the one, you're going to have one like this on your final. That's weird like this, that's out in no man's land. They won't have this as an option on your final. They get rid of the 0 and they just do this. So these are both right. You may encounter one or the other, okay? All right, so we have our p-value. Now we need to compare it to alpha. So remember, if alpha is bigger than the largest p-value, we reject. All right, our alpha is 0.05. And our biggest p-value is 0.001. So indeed, alpha is bigger, and according to our little cheat sheet, that means we are going to reject the null. Anytime you have those teeny tiny p-values, that means you need to change something. You're rejecting. The smaller the p-value, the more likely you're going to reject. Okay. All right, well, I didn't really mean to do that one, but that's okay. Still a right tail test. Okay, let's do critical value approach. All right, we get to draw a picture. We are a right-tailed test, so we only have one shaded region with one critical value. Do we expect our critical value to be positive or negative? Positive. Here's our non-rejection region. And the area of this little shaded region is alpha, right? That's what that means for critical value. It's just so much simpler. Okay, so critical value approach. Find T critical from the T chart using alpha as the area. Okay. All right. So we're still using degrees of freedom of infinity, right? Okay, our alpha is 0.05. So I'm here, 0.05. Looks like my critical is going to be 1.645. Everybody see that? 1.645. Now, I didn't have to divide alpha by 2. I didn't have to multiply alpha by 2. I didn't have to do anything because it wasn't a two-tailed test. Okay, so that's my critical value. All right, let's see where our Z observed falls. Our Z observed is 14.791. Where does that fall in our little curve? Yeah, way out here. It's kind of like out in the other building, right? Good gracious. So it's definitely reject. So again, you get the same result. Either way, you're going to reject the null. Okay. All right, so last week we did 2 sigma knowns. This week we did 2 sigma unknowns. Now let's do 2 proportions. And then that way you'll have all your Wiley problems covered. We'll do 14 and 18. And then we'll just see if we can do a few little review questions, and then we'll pick up on the rest on Thursday. Okay. All right, let's look at 14 and 18. Number 14, you can tell this came right off Wiley because it's got all your little boxes there. Okay, according to a Pew Research Center nationwide telephone survey of adults conducted between these 2 dates, all right, 55% of college graduates said that college education prepared them for a job. All right, the minute you see percent, you've got a proportion. You don't even have to think about it any longer. That's what you're dealing with. All right. Suppose this result was true of all college graduates at that time. In a recent sample of 1850 college graduates, there's my N, 59% said that college education prepared them for a job. Okay, we are in the same sentence as the sample and it's a percent. So that's our sample proportion. So he gets the hat, p hat. Remember, p hat's your sample, plain p is your proportion. Okay. All right, is there significant evidence at a 2% significance level? All right, that's alpha, 0.02, to conclude that the current percentage of all college graduates who will say that college education prepared them for a job is different from 55%. Use both approaches. Okay, so I don't see a null and I don't see a critical. No, good gracious, alternative. All right, let's do a null and an alternative then. Okay, so first let's look at the alternative. He's always the easiest to make to start with. What we want to know is he different from 55%? Okay, when you do your null and your alternative for sigma known and sigma unknown, you're using mu. Now that we're using proportion, you're using p. That's what you're using, okay? So for my alternative, how do I say different? What kind of test is different? It didn't say greater and it didn't say less. It didn't specify. It just said anything different. What do we think that is? Not equal to. It's a two-tailed test. When you see different, that means two-tailed test. That's going to be a question on your test 4, okay? So we are not equal to 55, which means our null is equal to 55, okay? So that's a tricky one. I want to make sure you can do that. And that also means two-tailed. So we're going to have to watch our alpha. We're going to have to watch our p. We're going to have to be really careful with the two-tailed because we got to do stuff with it, right? Okay, so if I flip my page to the very back where it says proportions, that's where we are now, okay? Here we go. No matter which approach we use, we need to find the test statistic first. We need to find z observed, okay? So here we go. We're going to have p hat minus p divided by sigma p hat, which comes from this, okay? Notice there's one thing we don't have, q. Now be really careful. Students know they need a q, but they get real confused. Do I need a q hat or do I need a q? When you're in chapter 8, you need a q hat. When you're in chapter 9, you need a q. So read these directions really carefully, right? Because it depends one minus which p you're going to use. Okay, so I need to come up with a q, which is going to be 1 minus p, not p hat. Oops. Switched my numbers. And there's my q. Okay, so be careful with him. All right, I'm going to do z observed. First thing I really need to do is that sigma p hat. All right, so I'm going to do a giant square root. I'm going to do p times q all over n. All right, and I came up with, put them down here, 0.01157. I just went out a few non-zero numbers. Did you guys get that okay? Did you get something else? Did you get that? Okay, all right. Okay, now for my z observed. All right, I'm going to do p hat minus p over that sigma p hat we just found. Okay, I'm going to get a z observed or a test statistic, same thing, of 3.46. So that's the first little box that it wanted up here for us to find. Okay. Is everybody okay with that? Okay. All right, now let's try our 2 different approaches. Okay, you won't have to do 2 different approaches on test 4, just in Wiley. Okay, let's find p-value. All right, so we get our little cheat sheet. Okay, We have Z observed. All right. Now remember, they're exactly the opposite. And you only use that t-chart for sigma unknown. So we're done with the t-chart. Okay, we're back to the calculator. You're going to use normal CDF for the p-value approach, and you're going to use inverse norm for the critical value approach. So for p-value, we're going to do normal CDF. Okay, now this is a two-tailed test, so it really doesn't matter if you use more of a right-tailed approach or a left-tailed approach. It doesn't matter as long as you multiply your answer by 2 once you get it. So you can either do Z observed as your lower bound and positive infinity as your upper bound, 0 and 1, or you can do negative infinity as your lower bound and Z observed as your upper bound, 0 and 1. Whichever one you'd rather do, but whatever answer you come up with, multiply it by 2. Okay, so I came up with 0.0003, and then I had to multiply it by 2, and my p-value is this. Okay. Did you guys get that okay when you did that in your calculator? Did it try to do the weird little e to the negative whatever on yours, or did it come out okay? It gave you the e to the negative? Okay, so don't forget that. If you get like 3, what did it give you? 3 e to the negative 4 or something like that? Oh, okay, e to the negative 4. Okay, so your calculator is going to come up with this. Remember, that's your calculator's way of saying this. And then when you move it over 4 places, you get this. And then I think it wanted 4 decimal places for P. So 4 decimal places, that's when it's going to turn it into this. And then you multiply it by 2 because you were a two-tailed test. Is that a little better? Okay, that's a little tricky. Okay, now we're going to compare it. So alpha is 0.02. Your p-value is 0.0006, right? So our alpha is larger. Remember, the smaller your p-value is, the more significant. So this means we're going to have to reject the null. Okay. All right, is that okay? Now we still need to do the find our critical values. Okay, I'm going to draw a little picture. Here's our rejection regions. Here's our non-rejection region. Alpha's 0.02, but we have to divide him by 2, and p-value we multiply, and this we divide. So our rejection region actually has an area of 0.01. All right, so now if we go to our little cheat sheet down here for critical value approach, it says to find Z critical, we're doing inverse norm, right? We do just the opposite, and we're going to use 0.01 to do that. So we're going to do inverse norm 0.0101, right? What did I come up with? I got negative 2.33. So that's going to be the critical value that's on the left. What's the one on the right going to be? Positive, right? And then I just plug those right in here to my little boxes. Okay. And now let's just make sure we do want to reject. So my Z observed was 3.46. So where does that fall in my picture? Yeah, over to the right, somewhere over in here would be where our 3.46 fell. So again, we're going to reject the null. Okay, so this little box is going to drop down. Let's see, this is not supposed to be there like this. And here's your choices. So it's going to say we can conclude that the current percentage of all college graduates who will say that college education prepared them for a job is, you have two choices. It is different from 55%, or it's the same as 55%. Okay, well, we rejected the null, which said it was the same as, which means we are accepting the alternative. So it is, in fact, different from 55% because we rejected the fact that it was equal to. Does that make sense? You won't have it tricky like that on the on test 4. It'll just say reject the null or fail to reject the null, but it's a little tricky there. Okay, let's do the very last one, all the way on the back of this big packet, number 18. Okay, is everyone doing okay with these? I know they're super weird. They're not hard, they're just weird, right? A lot of stuff to remember. You need me to scoot that up? Anybody? Okay. Andrew, did you need me to scoot it up, honey? Got it? Okay. All right. Okay, 18. Here we go. Okay. So according to a study, 11%, oh, I already know what it is. Proportion. Okay. Of children in the US lived with at least one grandparent in 2009. Suppose that in a recent sample of 1580 children, there's our N, 238 were found to be living with at least one grandparent. Now that's strange because with the proportion, this should have been a percent for me to turn to a decimal to make it equal to p hat. I gotta have a p hat, and that is not a p hat. Any idea how I get that proportion from these? We're gonna divide them. We're gonna do 238 divided by the 1580. That's a super tricky situation. That's only on Wiley. You won't have that on test 4, but put that in your calculator. And I came up with 0.1506. I'm just gonna keep the whole thing. Okay, that sound good? All right, so as soon as you know it's a proportion, you should have a p hat in the same sentence as your N. And if you don't, they'll at least give you a number on Wiley. In fact, I think they talk about grandparents. I think it's just right off of Wiley, and you'll know to do that. Okay, 2% significance level. That's going to be 0.02. Okay. Can you conclude that the proportion of all children in the US who currently live with at least one grandparent is higher than 11%? It wants both approaches. Of course it does, right? Okay, let's make ourselves some hypotheses. Since we're doing proportion, we're going to have P. All right, let's do our alternative first. I see higher than 11%. So what kind of symbol am I using? Greater than 0.11, which means the null is going to be equal to. All right, what kind of test gives me a greater than? That's a right-tailed test. Okay. All right, so we're on proportions. We're going to do a right-tailed test, and we're going to have to do both approaches. Okay, so here we go. Let's go ahead and find Z observed. We know we're also going to have to find sigma p hat first, right? Because it'll be our denominator. Okay, so sigma p hat has P and Q and N, and I don't have a Q. So I got to come up with a Q. 1 minus 0.11 is going to be my Q. So 0.89. Okay, so I'm going to have 0.11 times 0.89 all over 1580. Okay, so again, just to drive this point home, because I see it a lot on test 4, students know they have to do this, but inside sigma p hat, they put p hat and q hat. Do not put p hat and q hat. Follow these directions on here really, really carefully. It's P and Q, okay? All right, this gave me 0.007872. I think I just went for it, the whole thing. Okay, Z observed. I'm gonna have P hat minus P, remember P is your null, so you can get it from right up there, divided by that standard deviation we just found. And my observed is 5.158. Okay. All right, I'm ready for p-value. Okay, p-value approach tells me I'm going to be using normal CDF. Now I'm a right-tailed test. For a right-tailed test, I'm going to use Z observed as my lower bound, infinity as my upper bound, 0 and 1. Okay, so I'm going to have normal CDF, lower bound, upper bound, 0, 1. This is going to be my p-value. What did it come out as? What'd you guys get? 0, 0, 0, 0, 0, a whole bunch of zeros, right? So if you go out to 4 decimal places, what is it still going to give you? 0. That's a super weird situation. That's the situation when your null is so wrong, it couldn't get more wrong. You are rejecting it like nobody's business, okay? When your p-value is 0. Okay, so that's your p-value. They wanted it. It's 0. It happens sometimes, okay? All right, so my alpha is 0.02. My p-value is 0. Okay, alpha's bigger. We are going to reject the null. Okay. All right. Okay, last one of these doubles where you have to find it all. We need critical value approach. Okay, so normal CDF for p-value, inverse norm for critical. We're going to draw a little picture. This one also happens to be a right-tailed test. Okay, we don't have to split our alpha in two because we only have one area. I'm expecting a critical value that's positive. Okay, I need a positive critical value. Here's my non-rejection region. Okay, so I'm going to have inverse norm of 0.02, 0, 1. Okay. If you put that in your calculator, did you get negative 2.05 when you put it in there? Okay, so sometimes that happens because remember, technically inverse norm is the area to the left and we put the area to the right. I don't worry about it because I know what should my critical value be? Positive, because it's a right-tailed test. So just make it positive. Otherwise, the only way to fix that would be to go ahead and do 1 minus 0.02 and put an area of 0.98 in first. But I figure that's just more things to worry about. So if you have a left-tailed test, your critical value better be negative. If it's not, make it that way. If you have a right-tailed test, your critical value better be positive. If it's not, make it that way. If you have a two-tailed test, you got one of each, right? Okay, so here we go. And then I want to know, where is 5.158 in the scheme of things? He's out in here, right? So again, I'm going to reject the null. Okay. All right. And then don't forget about this little beauty down here. Remember, n times p does have to be greater than 5, and n times q does have to be greater than 5. Okay, we're not going to pack up. We're going to talk about test 4 study guide a little bit, but I just wanted to kind of get all chapter 9 done. That's the fastest I've ever done chapter 9 in my life. That takes forever. But is everybody kind of okay with the hypothesis testing? Like they could take something and figure out what page you're on and follow the directions and kind of go from there? Make sense? Okay. So these are all suspiciously similar to Wiley questions. So you ought to be able to knock them out. And Wiley is very short for chapter 9, so it won't take you long at all. Which brings us to our test 4 study guide. Okay, so The study guide is 35 questions long, but we already talked about the fact that a lot of them are just review. So I have a question for you. We only have about 15 minutes left. I was kind of thinking the study guide starts out with chapter 8 in the front and then goes into chapter 9, but your brains are deep in chapter 9 mode. Do we want to go to where chapter 9 starts, or do we want to go back and do, start here at the beginning with chapter 8? I kind of was thinking maybe we ought to scooch on over and kind of start on number 14, where the chapter 9 stuff is. I mean, what do you guys think? I don't want to make your brains hurt. That way it's kind of all goes in the kind of reinforces what you already learned. Would that be okay if we did it that way? Okay. All right. Let's start then. 1 through 13 is all about chapter 8. So let's do that Thursday, and let's start on number 14 then. Okay. So let's scooch over there. All right, so this is going to be multiple choice. So we'll be able to fly through this whole page really quickly here. All right, so let's see if we can remember. The null hypothesis is a claim about what? Okay, your null and your alternatives are both claims about a population parameter. That's super important, okay? Remember, mu has to do with the population. P has to do with the population. So they're about population parameters. Now, remember, the null is a claim that's true until declared false. Right? It's kind of like the justice system. You are presumed innocent. You're innocent. They have to prove that you're guilty. So the null is true. We are assuming it's true. It's true all day long until someone proves it wrong. Okay, does that sound right? So population parameter, true until you prove it false. Okay, number 15. In a hypothesis test, what's a type 1 error? And then number 16 is going to be what's a type 2 error? What's the difference in those two errors? Remember, type 1 is the really, really bad error. That's the one where the innocent guy goes to jail. So this is where you have a true null that's rejected, right? The true null is rejected. Okay, type 2 is the only other type of error that you could make, which is that a false null is not rejected. Okay, so again, these will be multiple choice. Just make sure you can pick them out. Don't get confused, because those choices get similar. All right, 17. The probability of committing a type 1 error is also called what? It's actually on the front page of your little cheat sheet down at the bottom. That's also the significance level. Now, we always call that alpha, but on your test, it's going to actually be written out in words, significance level. That's the same thing. So make sure that you can do that, okay? Significance level. All right, let's just do some signs then. So if we have a left-tailed hypothesis test, what's the sign of the alternative for a left-tailed? Less than. Good. It points toward the left, the little beaky thing, right? The little chicken beak. Okay. Right-tailed hypothesis. What sign are we looking at there? Greater than. Your little chicken beak is pecking to the right. Okay. All right. What if we have a two-tailed? What's our little alternative sign? Not equal to. And then for some reason, 21 is an absolute repeat. So I apologize. We already did it. Okay. All right. Here we go. Yolanda had a question. We want to answer it for her. Okay. So Yolanda wants to test if the mean price of houses in an area is greater than 145,000. What are the null and the alternatives? So then they would give you choices and you're going to have to write the null or pick the null and the alternative, right? Okay, so let's see. We need a null, we need an alternative. All right, and we're just going to use mu for all these. Don't worry about having a p in there. Okay, so if she's testing to see if it's greater than, what's the sign for the alternative? Greater than sign, right? Okay, and then your null is going to be an equals. There you go. Okay. All right. Kayla's wants to test if the mean annual salary of all lawyers in a city is different than 110,000. Write the null and the alternative. Okay. We're going to just use mu. That's all you'll have, so you don't have to worry about that. Okay, we write. I have such a hard time with that. I want to say we write. Okay, different than 110,000. So what's our alternative going to look like? Not equal to. That's what different means. So the null is equal to. All right. All right, Anna loves the children. She wants to test if elementary school children spend less than 30 minutes per day on homework. Well, I think they do. So, no, I think that's more than that. What are the null and the alternative? Okay, so we're going to use mu again. All right, less than for the alternative. There we go, less than 30. And our null is going to equal 30. Pretty straightforward. Okay, let's try the next one. Everybody okay with those? Pretty quick. Test is really not that bad. You just have 3 hypothesis tests to do. All right, let's look at 25. Okay. All right, so a calculator company has changed the electronics in its calculators. Previously, the calculator had a mean lifespan of 6 years. Maddie wants to perform a hypothesis test to determine whether the mean lifespan has changed. What are the null and the alternative? Okay, this one's not quite as straightforward. All right, we're going to use the null first. What do we think has changed? What do we think we're going to use? Not equal to. It didn't really say that it's worried it's higher. It didn't really say it's worried it's lower. It just wants to know, is there any change at all? Any change at all, you would do both tails, okay? And that would be the 6. And the null would be equal 6, okay? All right, let's look at 26. In a 2-tailed hypothesis test, with a significance level of 0.025, okay, what is 0.025 then equal to? What kind of little symbol? Alpha, okay? The p-value is 0.4. What conclusion can be drawn? Okay, you don't have to do anything except remember, and you can turn to any one of these p-values you want, but here's the situation. If alpha is bigger than the p-value, reject. If it's less than the p-value, fail to reject. It's that way on every single, proportion, sigma known, sigma unknown, they're all the same. So just turn to any of those tests and compare them. Okay, so my p-value is 0.4. All right, so is alpha bigger or smaller? It's smaller. Okay, and we know if alpha is smaller, and it doesn't matter which test we choose, we are going to fail to reject the null. And that would be our answer. Okay, so don't get hung up on that. And also don't let the 2-tailed throw you off. Okay, they've already done the calculations. It doesn't matter if it's a 2-tailed, right-tailed, left-tailed. You just take the numbers they give you. They've already handled all of that. Okay. All right, let's 27. in a hypothesis test for a population mean where sigma is known. Okay. They're telling us that for a reason, so we better get to the right page. Sigma is known is where we're looking, okay? The test statistic for the sample size of 55 was calculated to be negative 2.14. Okay, so N is 55. Test statistic, now we talked about that a little bit. What did we say test statistic was the same as? Z observed. That's the same, but they're going to use the language test statistic because that's what we used like 2 books ago. And Rita just can't quit talking about it. So we're just going to say test statistic. Okay, so we're going to find the p-value of this one-tailed hypothesis test. Okay, so it's a one-tailed. All right, so if it's either a right-tailed or a left-tailed, let's think about this a minute. We really don't know if it's right-tailed or left-tailed. I mean, 100% we don't know, but we can kind of guess because Z observed is negative. So do we think that would be a left-tailed or a right-tailed? Probably a left-tailed. I mean, you can only be absolutely sure with critical values. The observed values, you're kind of guessing, but we can kind of guess that. Okay, so sigma known, p-value. Okay, sigma known, p-value. We have Z observed already. That's our test statistic. We're going to do normal CDF. And we already said we're pretty sure it's a left-tailed test, right? So here's what we're going to use, just like this. We're going to do normal CDF. We're going to use negative infinity, lower bound. Our upper bound is negative 2.14, comma 0, comma 1. And then I came up with 0.0162. Okay. Is that okay? We're okay with that one? Okay. All right. Let's try 28. All right. The t distribution is used to perform a hypothesis test when what? What is the only time we go to the t-chart? Sigma's unknown. Now, they're not going to say sigma unknown. What are the words for sigma? Your population standard deviation is unknown. That's when we have to go to the t-table. Is that situation. Okay. All right, let's do 29 and then we'll stop. Okay. All right, so in a test of hypothesis for a population mean where sigma is unknown, okay, so we're flipping to unknown. Okay, Kayla and Yolanda, the dynamic duo, determined the test statistic for the sample size of 64, so N is 64, was calculated to be 3.257. Okay, remember, test statistic is Z observed. However, for sigma unknown, it's actually T observed. It's not a big deal. As long as something's observed, you're fine. Okay, is this. All right, now, it doesn't tell us it's a two-tailed test, so we're going to assume it's a one-tailed test. What kind of tailed test do we think it probably is since our observed is positive? Right. Okay, we want to find the p-value. Now, remember, sigma unknown, p-value, your p-value is a range. You're a range. Okay, we already know T observed. We already were given to us. Our degrees of freedom is going to be 63. Okay, we're going to use that T observed and find the 2 rows it falls between and go straight up to the top. Okay. So I'm going to go to 63. There's my row. Oh, I already have it written on there. Good grief. Okay. So it turns out 3.257 is way over here on this side. He's like not even between 2 written here. So if I go straight up, this is that weird situation you're going to have on the test where it's going to be between these 2. right? Between the 0.001 and the 0. But on the test, you're not going to have that option of both. You want to look for just the 1. Okay? Is everybody comfortable knowing how to find that when it's just the 1 on there? And then it kind of goes outside the bounds? Okay, good deal. Well, let's stop there.